Alright, CNT125, we're continuing our Chapter 7, and we're continuing our discussion on virtualization. Not only can we virtualize, a desktop computer or a server system, we can also virtualize network functions, network function virtualization, things like firewalls, emails, and that email applications, that sort of thing. So these things can also be virtualized as well. A software firewall is something like Windows Firewall that you have on your desktop. It's limited in scope and features, only services a particular client or a particular node. Meanwhile, a dedicated firewall, something like a Cisco ASA, like we're going to eventually use in our lab, that would actually protect all the nodes on a particular network or LAN, if you will. I can also create a virtual firewall. It emulates the actual physical hardware, like an ASA, hosted in virtualized environment. And there are things like pfSense by VMware, that's VMware Ready, Virtual Firewall Appliance by Netgate, Barracuda's NetGen Firewall F-Series, but these are a virtualized firewall, a virtualized version of a physical firewall. There is some limitations to it, but would have the capability of having an actual firewall function in your network with not actually the physical hardware. Sometimes these can be a little cheaper, might have a little bit of advantages maybe in the cost area, quickly adapt to things, migrate, that sort of thing, and that's what they list on the advantages here for you. I might not need multiple physical if I had multiple physical hardware firewalls before, I might be able to save some money by virtualizing one or two in my instance. And they can be quickly adapted, modified, migrated. They can be resources can be allocated based on need, and it can be scaled up as changes in the network occur. So they do have some advantages. The disadvantages is I still have the licensing issue. I would need the license for this. It's not like I can just copy it onto multiple hypervisors. It doesn't quite work that way. There is a small degree of latency between the actual physical hardware that it's sitting on and that virtualized system. And some actual, even diehard virtualization folks might be a little bit leery of actually using a virtualized firewall. But it does have its uses, and that's why they're at least mentioning him in this chapter with you, virtualize an actual firewall appliance kind of thing. There is also what's called software-defined networking. This is a centralized approach which removes the decision making from our devices like our routers, which we started working with a little bit in lab, getting a feel for what they do, removing some of that decision making up to a higher level, and the routers and switches just become the, hey, I will execute what you want me to execute kind of thing. And this is all then controlled with a network controller, software-defined controller, or a network controller handles that. That's where you program what happens in the network, and that communicates with the routers and switches and carries out what you want it to do. So in this case, they show you, okay, in a traditional network, the router, you program it with everything it needs to know and it runs for you. Meanwhile, in software-defined networking, you remove all that to a controller, and the controller is where you put all the rules in, the programming and all that sort of thing, and you just simply communicate to the switches and routers, I need you to do A, B, and C. And it goes, okay. So it literally is defaulting to the controller for any major decision that needs to be done. So you now have a centralized system of routers and switches carrying out what you want to have happen in the network. And again, this is becoming more popular where you're virtualizing your devices in your network, or virtualizing the control in the network, software-defined networking. And here they show you with that, the actual the devices are just simply carrying out the action. The control plane is where the software-defined controllers, software-defined networking controller sits, and that is making decisions, what's getting passed, what's getting denied, what's getting forward, what's getting blocked, that sort of thing. And then your application layer, your servers are communicating with that, saying, I need this to happen. Okay, I'll make that happen. I'll let the routers and switches know this voice call should be allowed through with higher quality of service than blah. So software-defined networking is something else that is kind of in the virtualization realm. There are a number of different network controllers out there, software-defined network controllers out there, including the major manufacturers. There's even some open source software-defined networking controllers, Open Daylight, Beacon, OpenShift, that are out there. You're starting to see some companies use this in parts of networks, reducing costs of things, pulling the control back to a centralized location. Alrighty, we'll come back in the next podcast and talk cloud computing.